Hi guys, my team and I will be presenting on a P&ID diagram that is related to a reverse osmosis process. This diagram is taken from a final project report that is by Southern California Salinity Coalition. The aim of the project is to reduce brine volumes that is being discarded into wastewater pipelines. Now I'll take you through the general design of the process. First, water will pass through a cartridge filter to remove small particles before going through a conditioning stage where anti-scalene and acid dosing is applied. After that, water will be pumped through to two separate reverse osmosis stages, and this is where separation happens. In the end, clean potable water will be recovered while excess concentrated brine will be discarded. Now I'll pass the time to my teammates to take you through the individual stages and components of the P&ID diagram.
Today, I'm going to talk about the pre-filter cartridge of the system. So, the pre-filter cartridge main function is to remove suspended solids from brine water entering to the RO unit. Brine water is fed to the pre-filter cartridge using a booster pump, and the filter is made out of polypropylene, which have a pore diameter of 5 micrometer. The operating capacity of the filter is 28 gallons per minute, also known as 106 liters per minute. There are two pressure gauges present in the filter. One is before entering the filter, one is after exiting the filter. The purpose of the pressure gauge is to indicate differential pressure of the filter, which when a sudden spike of pressure indicates cloggage of the filter, whereas a sudden drop indicates a rupture or leakage of the filter. Thanks.
Before the water enters the RO membrane stage, it is important to first apply some condition. The P&ID diagram shows that an anti-scalene pump is included in the pilot system for chemical dosing. Specification of the pump has a maximum capacity of 0.42 gallon per minute and a maximum operating pressure which is 110 psig. The anti-scalene pump is diluted to 2.55% in order to deliver recommended dose, which is 4 mg per liter. An anti-scalene pump is important to delay the reaction between the calcium magnesium and the bicarbonate present in the feed flow. If chemical reaction does happen, it will form scale on the RO membrane, which will affect the RO membrane performance. Careful observation on the P&ID diagram show that the anti-scalene pump is installed with low-level alarm (LLA) and the low-level switch, which is LLS. In the event that the anti-scalene flow from the pump is below the optimum level, the LLA will sound and the LLS will switch off the pilot system. Apart from that, an LMI chemical dosing pump is also inserted in the effluent stream coming out from the cartridge filters. The pump is used to control the pH of the water in the range between 6.5 and 7. In a nutshell, the exit stream from the cartridge filter will go through the anti-scalene and pH conditioning before entering the RO stage for separation. Thank you.
The next stage is the reverse osmosis stages. There are two reverse osmosis stages, which are reverse osmosis stage 1 and reverse osmosis stage 2. The fully conditioned water is pumped into reverse osmosis stage 1 by reverse osmosis feed pump. At this point, higher pressure is required to force the water past the reverse osmosis membrane. There are a total of 4 reverse osmosis units in a 2x2 formation. After purification of water in the reverse osmosis membrane, the permeate of two parallel streams combine into one stream to be channeled to the clean valves. The concentrate is then allowed to flow towards the stage 2 reverse osmosis for further separation process. So now referring to the P&ID diagram, it can be observed there is an interstage pressure boost located in between reverse osmosis stage 1 and reverse osmosis stage 2. Generally, the osmotic pressure of the concentrate exiting the first stage will be very high, and therefore a pressure boost is located before entering the stage 2 to generate more permeate. In stage 2 reverse osmosis, there is 2 units connected in series. Concentrate that exit the stage 2 will be channeled to be discarded as waste. There are several improvements to design reverse osmosis process, which are to design with lowest average flux, to design with lowest lead element, and also to design with lowest differential pressure of each stage. Thank you.
Okay. Recycle streams. Some of the concentrates are being recovered back into the conditioning system via recycle streams. The main purpose of the recycle stream is to reduce the amount of wastewater being drained out of the system. The recycle stream form a continuous loop from feed stream to output stream, and this process allows for the velocity of water to be maintained across the reverse osmosis membranes. In short, the recycle streams allow for the reverse osmosis system to achieve higher water purity. Companies can also save their profits by applying the recycle streams. This is because the disposal cost is significantly reduced. Data analysis. Based on our findings, the reverse osmosis process can produce high quality water. But given that the concentration of dissolved solids in the system must be less than 400 mg per liter, and the reverse osmosis membranes can perform at a recovery rate of 71% without any fouling. There are several improvements that can be made to improve the higher water purity. However, the silica concentrations must be consistently kept low.
Hi again. So my teammates have taken you through all the individual components and stages for the P&ID diagram, and we even provided some suggestions and recommendations to improve the system. Overall, the entire process flow is well thought, as it includes features such as using vertical pumps to replace horizontal conventional pumps to save space, as well as using an interstage boost pump to increase the pressure of the flow so that the speed of the flow from stage 1 to stage 2 of reverse osmosis stages will be fast enough to produce permeate. There are also safety precautions whereby the system will be shut down in the event that anti-scalene pump or the acid dose pump malfunction. This is important to maintain the performance of the system. Last but not least, data shows that the recovery rate is 71%, which is considered quite high in terms of performance level, and the water produced is considered as potable water, which is safe for drinking. That's all from us. Thank you for your time and hope you enjoyed the video. Thank you.